My name is Felecia Bowser, and I am a senior meteorologist at the National Weather Service in Shreveport, Louisiana.
And I'm Matt Hemingway, a journeyman meteorologist at the National Weather Service in Shreveport.
And we're going to discuss with you our poster regarding the meteorological and hydrological factors leading to widespread flooding in northern Louisiana during March of 2016. Heavy persistent rainfall, which fell during the second week of March 2016, resulted in one of the most significant flooding events to impact North Louisiana. Rainfall totals of 10 to 15 inches were commonplace, but a few locations, such as Monroe, Louisiana, which is east of Shreveport, Louisiana, exceeded 20 inches, which is denoted by the top center total rainfall graphic, where the white equates in excess of 20 inches. Although North Louisiana is no stranger to moderate and at times heavy rainfall, thus resulting in flash flood warnings, this event, however, was during the final months of an El Niño cycle, and the heavy rainfall prompted the issuance of flash flood emergencies, which were warranted as the high water resulted in school closures, major interstate closures, and home and business evacuations for many locations. This poster will speak to the synoptic and mesoscale features that shaped this historic flooding event. If you look at the top left, you'll see an East Pacific cutoff 500 millibar upper level low pressure system slowly move south-southeast to across the Baja of California and to across north of Mexico, where it became stationary for several days during the second week of March. Southwest flow aloft sharpened across North Louisiana, which opened the door for the atmospheric river known as the Maya Express to impact the area. The Maya Express is a fetch of moisture that extends along the western Gulf of Mexico and across the Yucatan Peninsula and into the Caribbean. As a result, precipitable water amounts soared into the 1 to 1.6 inch range. Concurrently, looking at the surface map in the top right, the surface low pressure system and its associated cold front moved onto the plains to across the four-state region where it became stationary. This front had plentiful moisture to work with, thus serving as an additional focus for heavy rainfall. The upper-level low-pressure system being cut off from the main synoptic flow led to its rather slow progression, and as a result, led to multiple days of very heavy rainfall. Matt will now discuss additional impacts this event had on the local rivers and lakes and surrounding communities, and the post-event consequences.
As Felecia noted, our focus during this event is not so much on the active El Niño during which this event occurred, but we would be neglectful for not mentioning its presence, especially as it relates to the seemingly endless supply of moisture from the Eastern Pacific that occurred during this week-long event. And in completing our poster, Felecia and I divvied up the workload where she focused more on the factors leading up to the event, which she just described to you. And now I'll transition to the actual event itself and the post-event consequences. It is worth noting, however, that the antecedent conditions leading up to this event were not particularly favorable for flash flooding, as much of North Louisiana experienced below normal rainfall for the 3 months prior to the event, as well as the preceding week, first week of March. The onset of heavy rain began to affect North Louisiana on March 8th and continued through March 13th. The heaviest rainfall occurred on the 8th and 9th, where combined two-day rainfall totals were over 9.5 inches in Shreveport and nearly 16.5 inches in Monroe, effectively 3/4 of the total event rainfall for the event, and that 3/4 of that fell in those 2 days, the 8th and the 9th. This resulted in multiple flash flood emergencies being issued over a large portion of North Louisiana, some requiring to be reissued, especially in northeast Louisiana where the heaviest rainfall occurred. So as expected, the axis of heaviest rainfall did orient itself along and east of the general placement of the stalled frontal boundary, as depicted on the surface analysis charts on the upper right of the poster. The rapid rise on area waterways following the 8th and 9th coupled with the continued rainfall over the next several days, ultimately resulted in record flood levels on several area lakes and bayous. Cross Lake, which is the water supply for the city of Shreveport, reached its all-time record crest of just over 177 feet on the 10th of March. And Wallace Lake, which is located in South Shreveport, also reached its all-time record crest, cresting at just over 160 feet on the 11th. And Caddo Lake, which is located in North Shreveport, reached its third highest all-time crest during this event. And several other area lakes and bayous also crested at or near record flood levels. Additionally, Interstates 20 and 49, which are the east-west and north-south corridors through North Louisiana, were both closed in both directions for a period of time at the height of the flooding. Interstate 49 was actually a bit later in reopening due to its route through South Shreveport, very near Wallace Lake, which took several days to recede. The Red River in Shreveport also climbed above flood stage for the third time in 9 months, eventually cresting on March 15th at 31.79 feet. And the river actually achieved one more crest above flood stage later in the spring, which broke the all-time record with 4 flood crests in less than a year. The Washita River in Monroe finally crested on March 25th, just under 46 feet, roughly 5 feet shy of the all-time record crest in 1958. And due to the more significant rainfall that occurred in northeast Louisiana, backwater flooding was even more significant than in northwest Louisiana, and thus the reason for the delayed crest until late March. Of course, the far-reaching effects of this flooding resulted in many state highways and parish roads remaining closed for much longer due to the extensive amount of backwater flooding along the Red River south of Shreveport, as well as the Washita River south of Monroe. This required our office to transition to a more post-event posture, recognizing the ongoing impacts well after the rainfall ended, and continuing to accurately account for these impacts with widespread aerial flood warnings. In a general comparison to the 2015 spring flooding which occurred in northwest Louisiana, by comparison, this event was far more widespread and impacted the entire northern half of the state versus the 2015 flood, which mainly affected areas along the Red River. This event had rainfall of 10 or more inches across just about the entire northern half of the state, and thus the heavier rain which occurred in areas generally from Shreveport to Monroe and Point South resulted in the significant flooding that went on to last for several days into weeks in some cases. Finally, it's important to note that Felecia and I teamed up on this project for different reasons. While I was able to work the duration of the event, Felecia was new to the office and came in after the event had occurred, so she was able to provide an outsider perspective as we went back and reviewed the event, and coupled with the first-hand knowledge that I had, we were able to collaborate and put together a very good project with this poster and really capture all the events, consequences, and impacts as we went back and covered all of the details. And we also wanted to mention that we did have a volunteer student from Jackson State University, Robert Garrett, who contributed to the poster as well, who did quite a bit of research on this event during the summer of 2016, and we wanted to credit him for that as well.
Thank you very much, and we hope you enjoyed this presentation.